Hey there, tech enthusiasts! Welcome to today's episode, where we're going to talk about one of the most fundamental components of modern electronics, the transistor. From the smallest smartphones to the largest supercomputers, transistors are the building blocks of modern technology. But what exactly is a transistor, and how does it work? Let's dive in and find out. A transistor is a type of semiconductor device that can amplify or switch electronic signals. It's essentially a device that can control the flow of electrical current. Transistors are made from materials like silicon or germanium, and they're incredibly small, sometimes smaller than a grain of sand. The transistor was invented in 1947 by John Bardeen, Walter Brattain, and William Shockley at Bell Labs. They developed the first working transistor, which revolutionized the field of electronics. Since then, transistors have become smaller, faster, and more efficient, enabling the development of modern technologies like computers, smartphones, and televisions. There are several types of transistors, each with its own unique characteristics and applications. Some of the most common types of transistors include bipolar junction transistors, BJTs. These transistors use both positive and negative charge carriers to control current flow. Field effect transistors, FETs. These transistors use a voltage applied to a control electrode to control current flow. MOSFETs, metal oxide semiconductor field effect transistors. These transistors use a combination of metal, oxide, and semiconductor materials to control current flow. So, how do transistors work? Let's take a closer look. A transistor has three layers: a base, a collector, and an emitter. When a voltage is applied to the base, it controls the flow of current between the collector and emitter. This allows the transistor to amplify or switch electronic signals. Transistors have a wide range of applications in modern electronics. Some of the most significant applications include amplifiers. Transistors are used to amplify weak electronic signals in audio equipment, radios, and televisions. Switches. Transistors are used as switches in digital circuits, enabling the creation of complex logic gates and microprocessors. Computers. Transistors are used in computers to create logic gates, flip-flops, and other digital circuits. Transistors have several advantages that make them essential in modern electronics. Some of the most significant advantages include small size. Transistors are incredibly small, making them ideal for use in compact electronic devices. Low power consumption. Transistors consume very little power, making them energy efficient and environmentally friendly. High speed. Transistors can switch on and off at incredibly high speeds, making them ideal for use in high-speed digital circuits. While transistors are incredibly powerful and versatile, they also have some challenges and limitations. Some of the most significant challenges and limitations include heat dissipation. Transistors can generate a significant amount of heat, which can reduce their performance and lifespan. Noise and interference. Transistors can be susceptible to noise and interference, which can reduce their accuracy and reliability. Scaling limitations. As transistors get smaller, they become increasingly difficult to manufacture and can suffer from reduced performance and increased leakage current. As technology continues to evolve, we can expect to see significant advances in transistor technology. Some of the most exciting developments on the horizon include quantum transistors. These transistors use quantum mechanics to control current flow, enabling the creation of incredibly small and efficient transistors. Nanoscale transistors. These transistors use nanoscale materials and structures to create incredibly small and efficient transistors. 3D transistors. These transistors use 3D structures to increase performance and reduce power consumption.